Blender's motion tracking workspace looks complicated, but once you understand what's actually going on in there, it's one of the most powerful parts of the software. Across 3 videos, we'll cover everything from preparing and tracking your footage, adding and lighting 3D models, all the way to compositing color and sound. And by the end, you'll have a solid understanding of the full workflow, taking normal footage like this and turning it into a 3D composite like this. In this first video, let's take a closer look at what's actually inside the motion tracking workspace and how it all fits together. Welcome to the first video in my Blender motion tracking series. In this video, we'll focus on preparing our footage and getting comfortable with Blender's motion tracking workspace. I'll walk you through where to input camera information and go through the main tools and key settings. This will help you get familiar with the interface before we jump into actual motion tracking. We'll be using free footage and doing everything right inside Blender so everyone can follow along easily. Let's get started! First, download the video clip for this tutorial. Go to the footage download page using the link in the description. Click the drop-down arrow to select the resolution. Choose the highest resolution and click Download Selected Size. Create a folder on your computer named something like Motion Tracking Part 1. Inside this folder, create another folder named Original Footage. Move the downloaded footage into this folder, then rename it into something shorter and more convenient. With the footage downloaded, it's time to prepare it for motion tracking. First, we'll convert the video into an image sequence. This is especially important if a camera uses frame compression, a method that reduces file size by saving only some frames and filling in the gaps by moving pixels around. While this saves space, it can cause problems with motion tracking. Converting to an image sequence ensures every frame is intact, making tracking more accurate. In Blender, press the plus icon and go to the video editing workspace. Press Add, then Movie. Navigate to your video and press Add Movie Strip. Match the resolution and frame rate to your video clip. To find these on Windows, right-click your footage, go to Properties, and then Details. Make sure that the area around the footage is black with no transparent pixels. You can use the Transform menu in the panel on the right to adjust the footage if needed. Set the end frame to match the length of your clip. Hover your cursor over the timeline and press Page Up to go to the end of your clip. Then go back 1 frame because Blender leaves the last frame blank. Copy the current frame to the end frame. However, I'm actually only going to use the first 250 frames for this tutorial. Create a folder where you want to render out the image sequence. Then set the output location to that folder. Set the output properties to PNG, RGB, 8-bit, with default compression. In the future, I'll go into file formats for professional workflows like EXR, but for now, let's keep it simple and focus on learning motion tracking. Under post-processing, make sure that sequencer is enabled. Inside render properties, scroll down and set view transform to standard. This ensures the colors will look the same as in the video clip. Finally, render the animation by pressing Ctrl F12. You should now have a series of images in the output folder that you selected. Let's import this image sequence into Blender and set up the motion tracking workspace. Open up a new Blender file. Press the plus icon and navigate to the motion tracking workspace. You only need a movie clip editor on top set to clip and another movie clip editor at the bottom set to graph. You can collapse the other windows. Press Open and navigate to your image sequence. Press A to select all, then hit Open Clip. In Output Properties, change the frame rate to match the original footage. In the panel to the left, click on Set Scene Frames. This will automatically set the end frame to match your image sequence. Then click Prefetch to load the image sequence from your disk for faster playback. You can see a purple bar appear over the timeline when you do this. If the bar hasn't been filled to the end, it means that only a part of it is loaded. To fix this, go into Edit, Preferences, System, and find the Memory Cache limit. This determines how much of your RAM is allowed to be used in the video sequencer. The default is set to 4096. This is equivalent to 4 GB of RAM. You can type in asterisk and 2 to multiply this value by 2. This will be equivalent to roughly 8 GB of RAM. You can increase this depending on how much RAM you have. I have 64 GB of RAM, so I will increase this to half of that, which is roughly 32,000. Blender won't crash if you set it too high, but if you are running multiple applications at the same time, your system might slow down. Half of your RAM should be okay, but if you feel like your system is slowing down, you can do less. Click Save Preferences. Then click the Prefetch button again. You should now see that the purple bar has been filled all the way to the end. Next, go into Render Properties and set the View Transform to Standard. Whenever we are dealing with real footage, this should be set to Standard. Blender can use camera data to improve motion tracking accuracy. In this tutorial series, we will let Blender handle it automatically, but I'll still give you an overview. Go to the right track panel, then open Camera. Here you can input the sensor size of your camera. The sensor size affects the scale and field of view in motion tracking. You can try to Google or ask AI for the sensor size of your camera. Pixel aspect ratio is important for anamorphic optics. Anamorphic squeezes a wide image to fit a smaller frame. It needs to be stretched back to look correct. Next, click on the Lens drop-down. Here you can enter the focal length of your camera. Focal length basically determines a lens's angle of view, or how zoomed in or zoomed out the image appears. The optical center is where the image is focused. This is difficult to adjust and is best left for Blender to calculate. Lens distortion makes straight lines look curved because of the lens. There's a trick to figure out what lens distortion values to use. In the upper Clip Display drop-down, enable Grid. The idea is that you can adjust the coefficients until the grid lines align with how the image is curved because of the lens distortion. There are a couple of different types of lens distortion. Polynomial is a general fix for lens distortion, mostly used for regular lenses. Divisions split the image to fix strong distortions, like those from fisheye lenses. Nuke follows the Nuke software model and is widely used in film production. Brown corrects detailed distortion, especially in older or complex lenses. But don't worry, if it's hard to see the distortion in your image, Blender can figure it out for you. Turn off the Clip Display Grid again. Inside of the Footage tab under Metadata, you can see the metadata of your sequence. It shows various technical details about the file. If you enable Proxy, you can build a lower resolution version of your video called a proxy. Then you can set the display preview to use this proxy for faster playback. This is useful if you have a slow system or are dealing with high-resolution file sizes. This should be changed back to full resolution once motion tracking is finished. The proxy will by default be stored in the same folder as your image sequence. but you can also choose a custom directory. That's all for the camera information section of the motion tracking workspace. As I mentioned, we'll let Blender handle these automatically in this tutorial. I just wanted to walk you through them so you're familiar with everything in the workspace. To start motion tracking, we first need to place a set of markers. Markers are points or features in the footage that are tracked over time. In the left track panel under Marker, you can click on Add. Then click on the viewport display where you want to place the marker. Here you can also choose to delete selected markers. The Detect Features button allows Blender to automatically detect features and place markers. This can save a lot of time, but knowing how to place markers manually can really come in handy in certain situations. The second way to add markers is with Ctrl left click. You can delete markers with X. You can grab, rotate, and scale markers with G, R, and S. A marker consists of a tracker and a boundary box, but to see the boundary box, you need to open Clip Display and enable Search. The inner tracker marks the spot you want to follow in the video. The outer boundary shows the area Blender will look in to find the tracker in the next frame. When you place a tracker, it defines the pattern at that location. In the next frame, it will search for the same pattern within the search area and snap to it. When tracking, the position of each marker is keyframed with X and Y coordinates. In the track panel on the right, under Marker, you can adjust settings for individual markers. These include position, pattern size, search size, and offset values. You need at least 8 markers to effectively track footage. Blender can then use the positions of the markers to calculate the motion of the camera. This process is known as solving the camera motion. There are 2 track panels we will use the most. The one on the left contains settings for markers you will create. The one on the right contains settings for markers you have already created. In the left track panel, you can change the pattern and search size. The pattern size should be large enough to capture the feature you are tracking. The search size should be large enough to keep the pattern within the area for the next frame. Notice that the pattern and search size of the already placed marker did not change when I adjusted these values. This is because the settings on this side only apply to new markers that you will create. To adjust the marker after it has been placed, you need to use the panel on the right. Next, there is Motion Model. A motion model defines the type of movement tracked in the scene. When the motion model is set to location, Blender only tracks how the feature moves across the image, just horizontal and vertical shifts, with no rotation or scale change. The location and rotation model lets the tracker account for both movement and rotation, which is useful if the feature slightly turns as the camera moves. Location and scale allows the feature to move and change size, which helps when the camera zooms or moves closer, making objects appear larger. The location, rotation, and scale option combines all 3 transformations, and is a good general-purpose choice for most camera movements. The affine model adds more flexibility by allowing skewing or shearing. It's ideal for tracking surfaces that tilt or shift in perspective, offering a good balance of flexibility and stability for most situations. Finally, the perspective model gives Blender full control to handle depth and perspective changes. It's supposed to be best for shots with strong parallax or when the tracked surface rotates significantly in 3D space. However, I haven't found a situation where perspective was actually needed. Affine is usually more stable and is preferred for more complex scenes. For most basic movements, location, rotation, and scale works well. Use affine when tracking elements that become skewed or stretched. You can try perspective if you have complex footage, otherwise stick to affine or location, rotation, and scale. Keep in mind that more complex motion models slow down tracking, so try to choose one that best fits your scene. By the way, what we'll be doing in this tutorial is camera tracking. In the right side track panel under Objects, you can see that we have a camera listed as the active object. That means we'll first be placing tracking markers on our footage to follow features in 2D space. Then Blender will solve the camera motion and give us an animated camera that matches the movement of the real one in 3D space. Then there's also object tracking. If you click the plus icon next to the list, a new object will become the active selection. If you're following along, save your file before making any changes. That way you'll have a clean version to continue with in the next tutorial. Object tracking follows the same principle of placing tracking markers, but this time on a moving object instead of features in the environment. Then Blender will solve the object motion and give us an object track that matches the movement of the real one in 3D space. So camera tracking animates the camera in 3D space, allowing us to place objects into the environment, while object tracking animates an object in 3D space, allowing us to replace or modify the tracked object. And we can have both camera tracking and object tracking in the same scene, as seen in this clip posted by the Blender channel on YouTube. Finally, we have one more tracking type, which is planar tracking. You can find it in the left Solve panel under Plane Track. This is the simplest of all tracking types. In fact, since it's so simple, let me just show you how to do a quick plane track right now. It'll be a little sneak peek of the tracking we'll start doing in the next video. First, make sure the camera is selected as the active object for it to work. Then I Ctrl left click some corners of this torn poster to place the markers there. Press A to select all markers, then Ctrl T to track forward until they go out of frame and stop. With the marker selected, click Create Plane Track. This creates a plane track outline that we can adjust to cover the area we want to mask out. It's more accurate to stay close to the markers, but you can expand the outline as well. The plane track outline is parented to the markers and will now follow them along the track. But this track isn't solved or used in 3D space. In fact, we don't even need a camera object to use it. Instead, Blender creates a 2D transformation that describes how a flat patch of the image changes across frames. This type of tracking is mainly used in compositing, so let's head over to the compositing workspace. Enable Use Nodes. Since we don't have a camera or any rendered elements, we can delete the Render Layers node. I prefer to disable Backdrop, open a new window, set to the image editor, and select the Viewer node to see my compositing results. Just make sure you actually have a Viewer node added. Next, I'll add the image sequence on my footage. Then add an image of my logo. We can use an Alpha Over node to composite it on top of the footage. To use our plane track, we need to add a Plane Track Deform node. Here, select the same image sequence that's loaded in the motion tracking workspace as the linked movie clip. Next, choose Camera as the tracking object. And finally, select the plane track as the input value. This node now creates a mask of our plane track outline, and all we need to do is drop it in between the image we want to fill the mask with and the alpha over node. As you can see, the image fills the plane track outline and follows the track. The plane appears to stick to the surface visually, but it's still basically a 2D motion. This means you can't move around it realistically, light it, or use depth-based effects accurately. You can think of it as a sticker placed on top of your footage. Additionally, once the tracks go off screen, Blender doesn't know what to do with the image, so it remains in the frame. You could try to fix this. For example, go to the last frame before the track goes off screen. Then, in the right track panel, under Marker, use the offset parameters to offset the track to another location. Or just use the shortcut GG to slide it to a new location with the cursor. I'll do that for both markers that went off frame. Then, with both markers selected, press Ctrl T to track them forward until they go off screen again. After that, go back to the frame where you started tracking forward and reset the offset to 0 again. Now the track continues along the offset location once the original track goes off frame. I'll quickly offset the remaining two markers that go off frame as well. While this is a viable way to maintain tracking data when a marker goes off screen or is temporarily obstructed during camera tracking, it's not very reliable during plane tracking. You can also see that the plane track outline starts to deform as the markers move away from the original surface, which shows that the planar transform is no longer accurate. But this offset technique can come in handy, so be sure to remember it. Plane tracking is best suited for areas that stay visible for the entire duration of the clip. If you want the surface to move out of frame naturally, you might as well track the camera, which we'll do in the next tutorial. Finally, I just want to mention that I tracked using only the location motion model. Choosing something like location, rotation and scale or affine will produce better results in this case. However, keep in mind that the panel on the left only affects new markers that are created. To change the settings of existing markers, you need to do it under Track Settings in the right track panel. Then you can track the selected markers forward again, and the track should be a bit more accurate now. So whether it's camera, object, or plane tracking, choose a motion model that best fits the motion of your tracked feature in the environment, on the object, or on the flat surface you're tracking. We got a bit ahead of ourselves and started tracking early, but I'll cover that in much more detail in the next part of this series. Now, let's jump back and go through the rest of the settings in the motion tracking workspace. Next, there is match type. You can choose between keyframe and previous frame. Keyframe compares the track to a fixed keyframe where you initially placed the marker. If tracking slips, you can manually reposition the marker. The tracker will treat that adjustment as the new keyframe to track. It's best for shots with little movement or changes. Previous frame compares each frame to the one before it. This helps the tracker follow points that get skewed or change shape. It's useful when the original pattern becomes unrecognizable. However, it can sometimes slip off track and is not always as accurate as the keyframe type. Pre-pass runs an extra tracking pass before the main tracking to help stabilize the result. It's best to leave this enabled. Normalize adjusts brightness and contrast in the tracked area. It's useful for tracking footage with significant lighting changes. Next, toggling R, G, and B lets you track individual color channels. Sometimes, tracking only one channel can save time and improve accuracy. For example, green screen footage might be tracked easier without the green channel. The Copy from Active Track button copies the settings from a marker into the left panel. This makes it easier to apply the same tracking settings to newly created ones. Under Tracking Settings Extra, weight lets you set the influence of a marker on the final solution. However, this is more relevant when we discuss settings for individual markers. Correlation controls how closely the tracker should match the pattern. A higher value makes the tracker look for a perfect match. A lower value allows it to track a pattern even if the match isn't perfect. Margin creates a space around the edges of your footage, where the tracker stops tracking. This is useful for preventing errors caused by lens distortion, or if the tracker gets too close to the edge of the frame and starts sliding in and out. Enabling Use Mask allows you to exclude areas that you don't want to track. To do this, go to View on the right and enable Annotations. You can choose to add an annotation either to the clip or to the track. For masking, select Track. To draw, hold D, left-click and drag. To erase, hold D and right-click and drag. You can mask out unwanted areas of your track this way. Adjust the opacity and thickness of your annotations using the sliders. Additional annotation tools can be found in the left panel under Annotations. Using annotations on the clip itself can help you stay organized. You can add multiple layers of annotations by clicking the plus icon. Now we've gone through most of the settings in the track panel on the left. As I mentioned earlier, these are the settings that will be applied to every new marker you create. After creating a marker, the panel on the right contains the same settings. However, the settings on this side will adjust each marker individually. They can also be adjusted multiple times throughout a track. Under Tracking Settings Extra on this side, there's also an additional setting called Frames Limit. This lets you track a marker for a specified number of frames. There's also Speed. This adjusts tracking speed, making it slower or faster. It doesn't affect the quality of the tracking, but it helps you monitor the changes. At this point, you can save your project if you haven't already in preparation for the next tutorial. I decided to break it up into episodes because I want to make sure that you fully understand each step. And that's why we're starting with the interface and settings in this tutorial, so that when we get to the motion tracking in the next tutorial, you'll feel more confident and less confused. In the next tutorial, we'll start motion tracking and set up our scene. If this tutorial was helpful to you, please like and subscribe. I'll see you next time.